Good evening and welcome to the live broadcast for our 34th Electron mission, a launch we've called Stronger Together for our mission partners Capella Space. We're bringing you a live view of Electron on the pad as we prepare for our second launch ever from our dedicated launch pad in Virginia at Launch Complex 2 on Wallops Island. My name is Felicity Powell.
And I'm Likita Satosala, and we're so glad to have you with us. We're about 16 minutes away from our target liftoff time of 1800 Eastern Local Time or 2300 UTC. It's hard to believe it's been just over 6 weeks since our very first launch from our dedicated launch pad at Wallops. On January 23rd, we launched to space from LC2 for our customer Hawkeye 360 and delivered their satellites to orbit with pinpoint accuracy. Those 3 Cluster 6 satellites are already providing useful Earth observation data from their new home in space. That mission marked a new era of dedicated small launch from U.S. soil for satellite operators. With the support of Virginia Space, the Commonwealth of Virginia, and NASA Wallops Flight Facility, we built Rocket Lab Launch Complex 2 to serve the responsive needs of the future and to offer ultimate flexibility for our customers, enabling them to launch from one of 3 pads across 2 continents. Combined, there's the possibility of more than 130 launch opportunities every year.
We also operate an integration and control facility within the Wallops Research Park, a short drive from the pad itself. Our facility is home to payload integration cleanrooms, vehicle processing facilities, and a mission control centre. The launch pad and production complex for Rocket Lab's large reusable Neutron launch vehicle will also be located here in Virginia. It's yet another way that we're streamlining operations across small and large launch as we build out the future of responsive space from Wallops. Construction is currently underway on the Neutron production complex and its launch pad, right next door to where Electron is currently standing. In fact, while we're preparing to go to orbit today for our customer Capella at Launch Complex 2, across the world in New Zealand at Launch Complex 1, preparations are already underway for our next launch for another customer. Our teams at both sites are looking forward to a busy year ahead. Speaking about being stronger together, though, today from Launch Complex 2, we are launching a dedicated mission for Capella, a leading provider of commercial synthetic aperture radar, or SAR imagery. SAR is a form of radar that is used to create 2-dimensional images or 3-dimensional reconstructions of objects, such as landscapes. We launched one of Capella's very first SAR satellites on another mission back in August 2020 on our 14th Electron mission called I Can't Believe It's Not Optical.
Our mission today would deliver 2 more of Capella's latest SAR satellites to orbit, enabling them to deliver the highest resolution, highest quality SAR imagery commercially available, empowering organizations across the public and private sector to make informed, accurate decisions based on what is happening across the Earth at any given moment. Here's more about Capella.
To reiterate, the goal of this pass is to establish contact and assess spacecraft health. Command, do you have any questions? Let's rock and roll.
We learn really fast, and we build satellites here in San Francisco. We learn things quickly, we go back in the factory, we make changes, and we go back to the launch site and launch new satellites. There's one team and one company in the world that could do this. It's this team and it's this company, it's Capella. And that's why we're the first and only American company that's ever been able to do this. I mean, we were the first American company to put a commercial SAR satellite. We're the highest resolution SAR imagery in the world in the most compact form. We're the first one that's able to do real-time tasking, which means people are going to be able to get their imagery as quickly as it's possible. So it's not just that we've done something as complex as putting a satellite up, we've put up the best satellite in space. And we've done that with just 100 or so people in a very short amount of time.
We're thrilled to be flying Capella once more and grateful to have signed an additional multi-launch deal with them coming up in 2023. These 4 missions are planned to lift off from one of our 2 pads at Launch Complex 1, with the flexibility to launch from right here at LC2 in Virginia, if campaigns require. All right, as we approach T-minus 12 minutes to liftoff, our operators will run through the final go, no-go poll by this mission's launch director. Let's hand over to Mission Control and check in on how we're tracking for launch. We'll be back with you shortly.
All operators, this is the LD on countdown, proceeding with the final poll for launch, go, no-go sequence, stage. Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCon.
VCon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
Mars CE.
RCE is go.
Mars Ops.
Mars Ops is go.
Mars One. And NASA GSO.
GSO go.
And NASA RSO.
RSO go.
MM.
MM is go.
And LD Sub.
LD sub is go.
And NASA TD.
TD go.
The go, no go sequence is complete. We are T minus 11 minutes, 9 seconds and counting. We are go for terminal count at T minus 10 minutes. From this time, the 3-word hold procedure is in effect.
So as we approach T minus 10 minutes and 40 seconds, Mission Control are reporting all systems on the vehicle are healthy and will be proceeding with the remainder of the count. We are still targeting liftoff at 18:38 local time or 22:38 UTC. Now, the satellites we launch open access to space to improve life on Earth. We're also on a mission to open access to the space industry through our global education programs designed to support young people to reach for the stars no matter where they're launching from. We work with schools and other organizations to deliver education programs that inspire, inform, and involve kids in the future of space and STEM, from elementary through to college level. Our flagship program is, of course, the Rocket Lab Space Ambassadors, which Lakita has been involved in for over a year now.
That's right. As a space ambassador, I've received training and resources to travel to different regions, visiting schools and community organizations to share what I love about space, STEM, and my job right here at Rocket Lab. The program helps me get involved with my community and support young people in their journey to become the future of our industry. We visited with over 19,000 young people in schools across New Zealand, the United States, and Canada since the program was launched in 2021.
Thanks, Lakita. That's awesome. Rocket Lab is very lucky to have our space ambassadors nurturing the next generation of space with their enthusiasm for STEM. Thanks to them, we've added more programs to support educators and communities in many different ways, such as our Space Educators program, the patch of which you can see here, which supports teachers and education leaders to deliver engaging space learning experiences. One of my personal favourite programs is, of course, Rocket Club, an after-school program where young Rocketeers learn how to design, build and launch their own model rockets with the support of our very own rocket engineers. We do have programs for kids aged 8 to 18 and beyond, and these are all offered through our network of over 500 Space Ambassador schools. It's free to register your school, college or community group on the network so that you can access Rocket Lab's education programs as well. Go to rocketlabusa.com/education to find out more about Rocket Lab's global education programs and see how you can get inspired, informed and involved with what we do. Thanks for joining us for this Stronger Together mission for Capella Space. We've come a long way from our first Electron launch in 2017. Rocket Lab started off with rockets as a small launch services provider, and we have now launched to space 33, nearly 34 times for our customers. Now we're also developing our large lift vehicle Neutron, and we have expanded our production capacity to in-space technologies. Through the acquisition of leading aerospace component manufacturers and the expansion of our teams across the United States, Canada, and New Zealand, Rocket Lab is making it easier than ever to get your idea on orbit. Here's Julie Kelly, Business Development Director, speaking to the exciting possibilities for Rocket Lab's Space Systems division.
My name is Julie Kelly. I'm the Director of Business Development for Space Systems for the Composites segment. So Space Systems is Rocket Lab's operating segment, including a wide range of spacecraft components, solar power solutions, separation systems, star trackers and reaction wheels, command and control software, X-band and S-band radios, as well as composite structures. We got into Space Systems to provide a vertically integrated solution for our customers. Our Space Systems division allows us to provide the Photon family of satellites and a range of satellite components to bring constellation volume and pricing to our customers. Space Systems heritage includes over 1,700 spacecraft on orbit with a Rocket Lab component. Some of the major missions that Space Systems has contributed to include the Mars InSight rover, Mars Ingenuity helicopter, NASA's James Webb Space Telescope, OneWeb's 600 satellite constellations, which brought global broadband connectivity. And of course, NASA's Capstone mission, which was a pathfinder to Artemis's mission to the moon. Since acquisition, we've been able to scale the Space Systems company in a number of ways. So first and foremost is a shared set of knowledge. So we've been able to use cross-collaboration or best practices, streamlining manufacturing. We've added manufacturing capabilities at a number of sites, as well as new product development. So we have one of the lightest, most efficient solar cells in the industry. We're working on next generation separation systems, expanding our reaction wheel portfolio, and investing into next generation products as well as new products. Rocket Lab is an end-to-end space company, and our goal is to provide a streamlined access to orbit for our customers.
It's always great to hear from our different global teams and what they love about the work we do together. If you want to be a part of that, there has never been a better time to build your career in space with Rocket Lab. We have plenty of job vacancies open at all of our 9 global sites, so check them out at rocketlabusa.com/careers. At just about 4 minutes to liftoff, we are approaching the handover to Electron's countdown auto sequence. At this point, Electron's flight computers take over the launch countdown. Our mission operators are reading the launch vehicle and payload as healthy and progressing through the count nominally. The weather is still looking good for launch at 2300 UTC. Moments after Electron has switched over to auto sequence, at about T-1 minute 30 seconds, we should hear the call that LOX loading is complete on the vehicle. At 1 minute to liftoff, we can expect confirmation that the launch vehicle's first and second stages are pressurized for launch. At T-10 seconds, you will hear our launch director, Joseph Carpico, make the iconic count to 0. Let's hand over now to Mission Control and listen in for these checkpoints. We will check back in with you shortly after liftoff.
LD GC countdown.
Go GC.
Stand by LD. LD GC countdown.
Go ahead, GC.
ECS disabled, pad auto sequence armed, pad ready for launch.
Roger, thank you. All operators LD on countdown. From now on, there should be no red flags on your critical LCCs. VCON LD.
LD VCON.
Confirm all expected flight computer ASGOs are green.
Confirmed.
VCON, lock auto sequence and confirm.
Auto sequence locked.
All operators, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
ECS is green for flight.
Oxload is complete. System is in recirc. Anti-geysering is disabled.
Stage 1, Stage 2 press for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting.
Deluge activated.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff.
Stage 1 propulsion is nominal.
Beginning pitch over.
And we're flying. Our 34th Electron vehicle is in the air and on the way to orbit after lifting off from Launch Complex 2. You can see the exhaust from those 9 Rutherford engines glowing bright as they propel the vehicle with Capella's satellites to space. Now that Electron has left the pad, its next milestone is max Q, the moment when the density of the air around the vehicle and its acceleration through that air creates the maximum aerodynamic pressure that the vehicle will experience in flight. You'll hear Mission Control announce this milestone soon enough.
Approaching max Q.
He will count you in, remember. Yep.
Saying max Q.
As you may have heard from our mission operator's call there, Electron has now passed through max Q. The vehicle has throttled back up to a velocity of over 1,000 meters per second, just a fraction of its maximum velocity as it proceeds to orbit. We're about to reach another 3 milestones in the flight, and each will happen quite quickly, so we'll explain all 3 in one go. To start, we need to separate the first stage of the vehicle from the second and third stage, also known as the kick stage, which holds Capella's satellites. The first stage is essentially a large fuel tank. Once that fuel is depleted, we jettison the tank so that the second stage can carry on to our orbital destination. To separate cleanly, we need to throttle down those 9 Rutherford engines on the first stage. This is known as main engine
Stage
cutoff,
1
or MECO for
nominal.
short. Once these engines have throttled down, the first and the second stage separate. Next, you'll see the vacuum optimized Rutherford engine ignites to carry the second and the
Please
third
stand by
stage
for MECO.
the rest of the way into space.
MECO confirm.
Stage separation successful.
Stage 2 ignition.
MECO, Stage 1 separation and Stage 2 ignition confirmed and completed. Our 34th Electron
Stage 2
mission is
propulsion
progressing
nominal.
nicely, and we're ready for the next set of checkpoints in flight on the way to delivering Capella satellites to their place in space. We are listening for the call to confirm that Electron's fairing, the pointing protective shell at the top of the rocket, has been jettisoned to expose the satellites in preparation for deployment.
Fairing jettison succeeded.
You can see it there on your screen. That's confirmation that the payload fairing has been successfully jettisoned and Capella's satellites are now exposed to space. Electron's second stage is continuing to orbit, travelling at speeds of over 8,000 kilometres per hour and currently at an altitude of over 100 kilometres.
That's another milestone checked off. The fairing is a millimeter-thin shell that serves a vital role, protecting the payloads inside from the awesome aerodynamic forces it sees as it breaks away from the atmosphere. Now that we're in free space, we can shed that extra weight to help maximize Electron's acceleration into orbit. Sitting on top of Electron, each payload might feel up to 8 times its own weight due to those
Stage
smooth
2 propulsion
accelerations.
holds nominal.
As part of the structural analysis team, our job is to prove every component on the vehicle is tough enough to withstand the stresses of all those forces, pressures, and vibrations on ascent, while still being a lightweight and elegant solution.
HVB discharge nominal.
T plus 5 minutes, and it's time for the next set of checkpoints in flight as we progress towards mission success. Next up is a milestone unique to Electron, the battery hot swap. You might already know that our 3D printed Rutherford engines are also distinct for another reason. They are powered by electric pumps. These pumps are powered by batteries, which eventually run out of juice. This is where the battery hot swap comes in. We need to swap the used batteries out with another fresh battery and jettison the expended ones to free up some weight, all while keeping that stage 2 engine running smoothly, which is why we call it battery hot swap. Sometimes you can catch a glimpse of these battery packs falling away, so keep an eye on the right side of your screen. While you do that, we'll listen in from the call out from Mission Control.
HVB
seconds remaining.
discharge nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Hot swap successful.
Stage 2 propulsion holds nominal.
Battery just in control.
Electron's second stage is now running on a fresh battery. You saw it there, with the battery hot swap confirmed successful by Mission Control. We're in the stage 2 burn for a few minutes longer, but the next major milestone we have is SECO, or second engine cutoff. Similar to MECO, which happens before first stage separation, SECO is when the Rutherford engine on the second stage will shut down just before the second stage separates from the kick stage, which of course will continue on to payload deployment.
Now at 7 minutes and 10 seconds into Stronger Together mission for Capella Space, the second launch from our US launch site on Wallops Island, Virginia, with 4 minutes until SECO and kick-stage separation. Electron continues to make its way to orbit, currently at an altitude of 6,000 meters per second and a velocity of over kilometers of around 200 kilometers, over 6,000 kilometers per second velocity.
Stage 2 propulsion still nominal.
If you're just joining us, we're T plus almost 8 minutes into our 34th Electron mission, which is going through all of the milestones well. It lifted off the pad on time at 18:38 local time and passed through max Q, MECO, first stage separation, and second stage ignition without any event. Of course, recently we've just had the battery hot swap, and we're just waiting on SECO, second engine cutoff, before the kick stage separates from the second stage.
As Felicity mentioned
burn out to
earlier,
take mode.
coming up next, the engine on Electron's second stage will throttle down and shut off
Stage
before
two
the final
propulsion
stage
nominal.
separation. From there, we'll go into a coast phase in an elliptical orbit for
Guidance
about
and
40
terminal,
minutes or
22
so
seconds
until the
remaining.
kick stage ignites its Curie engine and propel the Capella Space SAR imaging satellites on board to their exact targeted orbit before they are deployed. Payload deployment will mark the end of the mission, which will occur at around T plus 60 minutes or so. So let's listen in for SECO and kick stage separation.
SECO confirm.
Nominal transfer orbit achieved.
Stage 3 separation confirmed.
The space-optimized Rutherford engine on Electron's second stage has now throttled down, and the second stage has cleanly separated from the kick stage. The SECO and second stage separation milestones for this mission are complete. The next phase of the mission takes a little longer than that action-packed first 8 minutes after launch, but it's worth the wait. Electron's kick stage, with payloads attached, will now enter the coast phase that Lakita mentioned, as it propels the payload in an elliptical orbit towards the apogee requested by our customer, Capella. Once it has arrived at the requested orbit, the small but mighty Curie engine on the kick stage completes one final injection burn to raise the perigee of that elliptical orbit so that the orbit is circular. After circularizing this orbit, we can then deploy Capella's satellites and wish them well as they settle into their new home in space. We will have a simulated view of this payload deployment, plus live feeds from Mission Control, so stay with us on this webcast. We'll be back with you at T plus 51 minutes. See you soon.
Welcome back to the live webcast of Rocket Lab's 34th Electron mission, Stronger Together. I'm Likita Satrasala, and this is Felicity Powell, and we're glad you could join us this evening. Our mission has been by the book so far, with the vehicle lifting off at 18:38 local time or 22:38 UTC from LC-2 on Wallops Island, Virginia. Electron passed through max Q, MECO, first stage separation, and second stage ignition before reaching the T+3 minute mark.
At T+6 minutes 16 seconds, the vehicle completed a successful battery hot swap and then followed up with SECO and separation of the kick stage at 9 minutes 14 into the mission. The kick stage proceeded on its first pass of an elliptical orbit and is now completing that coast phase. Up next is payload deployment of those 2 satellites for Capella Space. Let's take a look at this animated simulation of what that will look like and listen back with Mission Control.
Payload deployment confirmed.
And that's Mission Control with the good news. We have successfully deployed Capella's satellites to orbit, and with that, we've completed our 34th Electron mission. A massive thank you and congratulations to our customer Capella and all of Rocket Lab's teams for another mission success. And of course, thanks to you and everyone who has followed along at home to share this moment with us.
This concludes our broadcast this evening, but remember to follow Rocket Lab's Facebook, Twitter, and Instagram pages for more information on our next mission. It might be happening sooner than you think. This is Rocket Lab Mission Control, signing off.